We are now on the elementary applications of differential equations. So we are done with the velocity of escape that is based on the Newton's law of gravitation. So now we are going to discuss on the elementary applications of DA using Newton's law of cooling. So the formula is the rate of change of the temperature of the body with respect to time is directly proportional to the temperature of the body minus the temperature of the surrounding, or that is proportional to the temperature of the surrounding minus the temperature of the body. So whichever will give us a positive value, that is our formula to be used. So that is equal to K times TB minus TS, where K there is the constant that is the required in getting the temperature required in a given problem. So we're going to get first the constant for that. Okay, to be able to get the constant K, we are to separate the variables. If you remember your separation of variables, so that is over, let us divide it by TS minus TB. We're going to cross multiply that, that is K times dt. Okay, now we're going to differentiate first. TS minus TB there, where TS there is constant and TB here is a variable, so the differential of TS there is 0 minus the differential of TB there, since that is a variable, that will become dTB, so that is negative dTB. So if you can see here, the numerator dTB doesn't satisfy this one, the differential of this one, so we are going to manipulate this equation. Okay, so we are going to multiply it by negative, that is negative dTB over TS minus TB. Since we multiplied negative, make sure that you divide it by its reciprocal, that is 1 over negative 1 over 1, so that is the same, that is 1. So that is K dt. Now we are ready to integrate that one. Now integrating that, it will give us, let us bring out negative, that is the integral of negative dTB over TS there is constant minus TB there is our variable, that is equal to, let us bring out K since that is constant, so that is dt. Okay, so integrating that, it will give us the negative ln of the absolute value of TS minus TB, that is from the lower to upper, that is equal to K, and the integral for dt, that is t, so that is to lower to upper, that is our limit. So this will be our working equation. Okay, if that will be our working equation, let's have an example. A thermometer reading 18 degrees Celsius is brought into a room where the temperature reading is 70 degrees Celsius. So at time 0, that is 18 degrees Celsius, and the temperature of the surrounding, that is 70 degrees Celsius. So after 1 minute has passed and the thermometer reading is already 31 degrees Celsius. So determine the reading 5 minutes afterward it is brought into the room. So let's have the given. So our TS there, the temperature of the surrounding, that is 70 degrees Celsius. And it says there, at time is equal to 0, the temperature of the body is equal to 18 degrees Celsius. And at time is equal to 1 minute, your temperature of the body there is already 31 degrees Celsius. So we are asked to get the temperature of the body at time is equal to 5 minutes. If that is our given, let us tabulate that one. So let's have here the time, and here for Ts minus Tb. So at time 0, our Ts there is constant, that is 70, minus that is 18, that is equal to 52. And at time 1, that is Ts minus Tb again, that is 70 minus 31. So that is 39 degrees Celsius. And at time 5 minutes, that is constant minus, this is the temperature of the body. Okay, so using solution 1, that is using the Newton's law of cooling, our working equation is negative Ln the absolute value of Ts minus Tb, that is from upper, this is lower, is equal to Kt, that is upper, and this is lower also. So our limits will be from here to here. So let us substitute the values, that is negative Ln, the absolute value of Ts minus Tb. So our upper there is 39. This is 52. This is from 52 to 39 is equal to K. T. Your time there is from 0 to 1. Okay. So we substitute the values here, upper minus lower. So it will give us the negative Ln of 39 minus negative Ln times 52 is equal to K times upper minus lower, that is 1 minus 0. Okay, so simplifying that, it will give us Ln of 39 minus, that is plus already, that is Ln of 52 is equal to K. So let us recall, don't forget that Ln of A, if that is positive, and Ln of B, that is negative. So our numerator there is A and our denominator there is B. So don't forget that. So rewriting this one, that is the Ln of 52 over 39. So that will be your value of K. So that is equal to 0.28768. So that will be our constant. Okay, so if that is our constant and that is our working equation, let us substitute this one. So this will be our limits now. That is for Ts minus Tb, and this is for T. So let us substitute that, our requirement. So that is Ts minus Tb. Our upper there is 70 minus Tb, and our lower there is 52. And that is equal to K times T. So that is from 0 to 5. Okay, that is the limit. So if you're going to substitute that, that is upper minus lower, that will give us negative Ln of the absolute value of 70 minus Tb minus the Ln of the absolute value of 52 is equal to K times upper minus lower, the time, that is 5 minus 0. Okay, so if we're going to simplify this, that will become Ln of 70 minus Tb plus Ln of the absolute value of 52, that is equals to 5 times K, where K there is equal to 0.28768 already. Okay, so that is, let us rewrite that one, that is Ln of 52 over 70 minus Tb, since this is negative, so that is equal to 0.28768 times 5. Okay, to be able to cancel Ln there, let us raise that to E. The same with this. So E raised to Ln, that is equal to 1, so that will become 52 over 70 minus Tb is equal to E raised to 0.28768 times 5. Continuing that, to be able to get TB there, let us cross multiply. So it will give us 52 is equal to 70 minus TB multiplied by e raised to 0.28768 times 5. Okay, so we're going to simplify that. That will become 70 times e raised to 0.28768 times 5. That is minus TB e raised to 0.28768 times 5. Okay, let us transpose TB there. That will become TB is equal to, that will remain 70e 0.28768 times 5 transposing 52. That will become negative 52. Okay, let us divide it by the coefficient. This is e raised to 0.28768 times 5. So your TB there, the temperature of the body at T is equal to 5 minutes. That is equal to 57.66 degrees Celsius. Now, if that will be our table, so let's have our solution 2 using the calculator. So your x will be here, and then your y would be there. So if we are going to use your calculator, you press mode first. Press mode, and then you choose 3. That is for statistics. And then for type 4, for ln of x, so your x there corresponds to 70 minus 18. You press equals, then next that is 70 minus 31. So press equals again, so let's bring that up so that your time is 0 there for 52, and then for 39 that is 1 minute, so press equals. And then press AC, and then you shift, that is stat for number 1. You type there 5 for regression, so you choose 4 there to be able to get TS minus TB, since that is our x, that is x hat or x current, so that is 4. So we are required to get the TS minus TB there at 5 minutes, so press equals. So that will be the temperature, that is 12.33984,375 degrees Celsius. Okay, if that will be your x hat, that is TS minus TB, don't forget that your temperature of the surrounding, that is equal to 70 degrees Celsius. So substituting that, that is 70 degrees Celsius minus the temperature of the body after 5 minutes, that is equal to 12.33984,375 degrees Celsius. So transposing, that is TB is equal to 70 degrees Celsius minus 12.33984,375 degrees Celsius. So the answer is the same, that is equal to 57.66 degrees Celsius also.